Hey everybody, and welcome to this week's Learning with Lindsey. The thing that's been going on for our weather this past week has been we've had these storm motions from east to west, and that's pretty atypical for us this time of year. Normally we're seeing storms move from the northwest to the southeast or from the west to the east, just based on our prevailing trade winds, or we have, the jet stream that just pushes our storms out towards the east. So this has been a little bit backwards, and I wanted to just break down a little bit of what's going on at some of our upper levels as to why these storms are moving from east to west. It's definitely happened before, but I just thought it was a very great Learning with Lindsey topic to really explain. So we're starting with the basics. When you're looking at, the entire Earth, the whole world, we've got these different, they're just circulations. We've got the Hadley cell, the Ferrel cell, and the polar cell, and it's both in the southern portion of the world to the northern portion of the world. These three massive loops, massive, they take up the whole world, on, again, north of the equator, south of the equator, are loops of moving air that drive Earth's global weather patterns. They redistribute the warm air at the tropics around the equator to the poles, and that movement causes a lot of surface level storm systems, especially with this Ferrel cell. There it is. And that's going to be in the United States. So that's what we get a lot of the time. So when we're looking at what these circulations, these loops actually cause, they cause the northeast trade winds, and this is from the tropics to about 30 degrees of latitude, and that's where we mostly have our hurricanes. The active season of the hurricane starts with some hurricanes developing and moving westward, and then our storm systems, mostly in central and northern United States, we see all of our storm systems move from the east or from the west eastward, and that's due to our westerly winds. Then you can see polar easterlies, those are causing those storms to move a little bit more from the northeast to the southwest. So it all just really affects what's going on more at a surface level. These trade winds cause the hurricanes to move from the east to the west, but our westerlies, opposite. That's going to cause our storms to move eastward. So our main two cells that we really deal with, especially, if you're moving further south in North America and even into South America, you're mostly affected by the Hadley cell. And this Hadley cell is warm, moist air near the equator. It heats up and it rises, creates clouds, heavy rainfall. So you're getting the tropics, you're getting all of that moisture and the nonstop monsoon seasons. As this air moves towards the poles, so it's going to move north towards the poles, it cools and becomes dense and sinks. And we all know what sinking air causes. Sinking air will drop down and cause the dry climates, and it will also cause high pressure systems. That's right around, where we've got the Arizona desert, all of that going on. And this is pretty much the main cause of all of our major deserts like the Sahara. Then we flip over to the Ferrel cell, and that's what causes most of our weather patterns in the United States, and that's kind of this middle gear between the Hadley cell and our polar cell. So this is indirect. It's not actually caused, by the differences in temperatures from the equator to 30 degrees latitude, but it's caused by being in between the Hadley cell and the polar cell. That's about 30 degrees to 60 degrees in latitude. The surface winds here will blow poleward, but are deflected by Earth's rotation, the Coriolis effect, and it creates these prevailing westerlies. They shape the temperate zones. It acts like a major mixing zone for tropical weather and for those cold polar air masses that we'll see, especially when we're getting into the changing seasons. So this is what causes most of our daily changes in the weather, is that Ferrel cell. The storm motion in the United States, it follows that global wind pattern, that Ferrel cell, the prevailing westerly winds, and the jet stream. So these are high altitude currents that are driven by Earth's rotation and pressure differences. And they drive most of our surface storms. But why are we getting still storms that are moving from east to west? That's mostly we've got a couple of different reasons. We've got a cutoff low, that's a possibility, and we also have atmospheric blocking, which is when we get a high pressure system blocking in our area. You may have heard some of us talk about that before, the blocking high or the mega high. That can cause some consistent storms, and we'll get to that in a little while, but actually what we're dealing with is the cutoff low. So it's an upper level low pressure trough. It's a short wave, that's what I like to call it, and it gets detached from the main jet stream. When that happens, then you get a different kind of storm motion with that. So without strong steering currents from the west, those westerly prevailing winds, the storm's counterclockwise circulation causes it to drift westward. And that's what we're having. So this is a map of the upper level airflow, the jet stream that we've got ongoing across the United States right now. So we have, you can see it's a little cut off, but out far to the northeast, we've got this low pressure system. And with that, you know, you can see this that high pressure system setting up across most of western United States, northern United States. But because this little low pressure system, and you can see based on these little lines how it's originally connected to the northeast low, that's being pulled out to the west because it's getting cut off from the jet stream. And then with that high pressure system just north of it, it's going to settle in, especially further out east, and then drive that low even further to the west. And so that's what is causing, you know, our storm motion to be from east to west. This area of low pressure sitting over the southeast right now is that area that's getting cut off from the jet stream, and eventually it'll get so far away from us that we won't have to deal with the daily chances of storms. But because it's so slow moving, it's just drifting out to the west, and then that high sets up and kind of pushes it a little further. That's what's going to cause the afternoon storm chances that move from Alabama and eastern Mississippi over to the areas in southwestern Tennessee and northeastern Arkansas. So it's all kind of going backwards. And I just found that to be very interesting, a great topic to talk about for this week's Learning with Lindsey, because it's so prevalent for what's going on right now and over the next couple of days. But because we had some strong storms on Saturday, it really just brought in some cooler temperatures, and then this cutoff low moving so slowly to the south of us, we're still getting the northerly winds, and that's also helping keep us cooler as we head through the first half of the week. But eventually that high pressure system really does just take over, and then the heat returns, and that sinking air that we associate with a high pressure system returns as well, which means we won't get as much chances of rain, or as many chances of rain through the weekend, especially once that low gets further out to the west over Texas. But that is our Learning with Lindsey for this week. Now, if you have any other questions or weather-related questions or topics that you want to be discussed or you want to know more about, you can email us at weatherquestions@wreg.com and be featured here on a Learning with Lindsey episode.